Welcome back. This is review number 8. We're doing trigonometry today. Question number 1 says, which of the following trig functions has the longest period? Now, period is the time it takes for you to make one complete cycle of your trig function. Or if you're looking at equation, like in question number 1, the period is the formula 2 pi over b. So what I did to save a little time is I did 2 pi over, here's our b, pi over 4. So to simplify this, we're going to do 2 pi, change to multiply, flip the fraction. Pi's cancel out, so you're left with 8. So our period for option 1 is 8. For option 2, it says a cosine function with a relative maximum at 5, 6. So I put a dot here. And a relative minimum at 8, -1. So to make a period, it's from here all the way to here. And from 5, 6 to 8, 1, this is like 3 boxes long, which means the total length or the total boxes would be 6. So it takes 6 squares to get from there to there. So the period here is 6. For option 3, start at your y-axis. How long does it take to get back to your starting? Right there. So I'm going to say this is about 12 spaces to get from the beginning back to the beginning. And over here, I graphed it already. It takes till 4 pi. Well, it's hard to compare regular numbers to something in terms of pi. So I'm going to do 4 times about 3.14 because that's pi, and you get 12.6. This is the longest period. That is a very typical type Regents question, just for frame of reference. So for question number 2, it says, if sine theta equals 7 over 25, where theta is an angle in standard position that terminates in quadrant 2, what is the value of tangent theta? So I drew a triangle in quadrant 2. This is my right angle. This right here is my theta. It's kind of a bad theta, but that's okay. And I know sine is opposite over hypotenuse. So from theta, opposite is 7, hypotenuse is 25. In order to find tangent, that's O over A. So we need that x side. So I'm going to do Pythagorean theorem to find that missing side. So 7 squared plus b squared, we don't know what that is, equals 25 squared. So 49 is 7 squared, and 25 is 625. I'm going to minus 49 from both sides. So I end up with b squared equals 625. It's not 625, hold on. So b squared is 576. When you square root that, you get b equals 24. So I'm going to put that 24 right here. And now to find tangent theta is O over A. O over A. 7 over 24. Which is, I was just going to say which is option 1. But we know this is actually negative. When you use Pythagorean theorem, it's always going to give you a positive value. But because it's in quadrant 2, tangent is negative in quadrant 2. So it would be negative 7 over 24. Good catch. Usually I get those wrong. Okay, there's my picture. Number 3 says a circle centered at the origin has a radius of 13 units. The terminal side of an angle theta intercepts the circle in quadrant 3 at point C. So I'm going to make a radius of 13 somewhere in quadrant 3, like that. This purple now makes a triangle. Here's our right angle. This guy in here, that's our theta. So the radius is the same thing as a hypotenuse. And it also says the x-coordinate of point C is -5. What is the value of sine theta? Now you could use Pythagorean theorem again, but we do know there's a 5, 12, 13 right angle. So that's a 12, and before I forget, it's a -12 because it's quadrant 3. So sine theta, remember it's not just sine, it's sine theta. O over h, so it's -12 over 13. Last one, I believe, on this page. Relative to the graph of y equals 3 sine x, what is the shift, and it literally moved up on my paper, of y equals 3 sine x minus pi over 6 plus 4. So the 3's, those didn't change. What did change? This. It's in parentheses, so that means we're shifting left or right, and remember, it's always the opposite. So we're going to go right pi over 6 units, and then this is up 4. So it would be option number 1. So technically we didn't do word problems in our curriculum, but I did leave some in just because I thought it was good to see how this stuff applies in semi-real life. A sine function increasing through the origin can be used to model light waves. Violet has a wavelength of 400 nanometers. Wavelength is the same thing as a period. Hey, oh, really bad writing. Oh. Yep, I just did that. I just deleted my graph in the hallway, got distracted. Okay, try again. Hey, so here's my sine wave. Wavelength is the same thing as period. So right here, this would be 400, which means this middle part is 200 on the x, and obviously there's the origin. We got 100 and 300. So now the question says, over which interval is the wavelength increasing? So it's increasing here and here. In the red section, it's decreasing. So from 0 to 200, it goes up and back down. 200 to 400, it looks like that. 100 to 300, it's kind of like this. But from 300 to 400 right here, it's increasing. So that's your answer. Number 6 says, which statement regarding the graphs of the functions below is untrue? So it went on to my other paper. So we have 4 functions, f of x, h of x, g of x, f of x, g of x, h of x, and j of x. So let's look at these options. F of x and j of x have a max value of 4. So we're looking to see which one is false. J of x, if you graph this, its absolute value, the arrows point down, and the y-intercept is a 4. So that is true. And for f of x, 4 cosine 3x, we know the midline is 0. We know the amplitude is 4. And maximum is midline plus amplitude, which gives you 4. So both of these are true. I'm going to go through these and then erase because it's just going to get too messy. Option number 2. G of x, h of x, and f of x have rational zeros. So let's see, g of x, if you set all of those factors equal to 0, you get x equals negative 0.25, x equals 3, and x equals negative 1. So that's rational. For h of x, let me graph this. graph looks like that. If you look on your tables, this does have a rational zero. And j of x, if you graph this and you check the zeros, these are also rational. This is true. Number 3, let's go to orange. G of x and j of x have the same end behavior. So let's see. G of x, that is a cubic. So it would look something like that. So that's g of x. J of x is that absolute value. So as x goes to negative infinity, that arrow points down and that arrow points down. So that is true. The last one is obviously false because it says h of x has one y-intercept. H of x is our logarithmic function, and there is an asymptote at the line x equals 0. It never crosses the y-axis. So that is false. So number 7 says, which equation represents an even function? And for an even function, you have this rule over here. If you have a point that's an xy point, to be even, the x gets negated. So what I'm going to do, and what you should do at the same time, pause the video, go through each one of those and find points on the table. See which one fits that description, even function. So what I did was I went through each one and then I wrote down some points. So for the first one, I got the point negative 181. If this was an even function, the point positive 181 would also have to be on the graph, and it's not. So for option 3, I'm just working in the column, I have the point negative 1, 1.1585. To be even, I would have to have the same point except a positive 1, and I don't. The only one where this works is number 4. I have the point negative 1, 2.5, and positive 1, 2.5. Last question. Which graph represents a sine function with a horizontal shift, or with no horizontal shift, an amplitude of 2, and a period of 2 pi over 3? So first, we're looking for a sine function. So if the y-intercept is a max or a min, that means it's cosine. So this says an amplitude of 2. This is your amplitude right here. It looks like they both have an amplitude of 2. And a period of 2 pi over 3. So 2 pi over 3 is about 0.67 pi, 2/3 pi. So here's this graph to get all the way here. And then, so they look like they take the same distance. But this pi over 3 is actually 1/3 pi, and this is a 1 pi. So option 2 comes closest to 2/3 pi.